All right, the next part of functions we get to look at is function notation. So we talked about what it takes to get a function. Now, once we know we have a function, what's the notation that's used? So if we have y is equal to f parenthesis x, this part is function notation, and it is referred to as f of x. So y is equal to f of x. That's just the words that we use whenever we talk about function notation. So anytime you have this f of x notation, you automatically know it's a function. Now, this is an f with parentheses x. That does not mean f times x. That is simply function notation. Whenever people solve, a lot of times they want to try to solve for f all the time, and that is not what you're doing here. That is the actual function notation. And this is how it's used. So if I have f of x is equal to a negative x squared plus 5x minus 3, and I want to find f of 2, what we're actually looking for here is the fact that the 2 replaces the x. So f of 2 in this instance just means I'm going to take that 2 and put it in place everywhere I see an x. And then solve. So my input value here, my x value, is a 2, and we have to figure out what the output or the y value is. So f of 2 is now equal to a negative 4 plus 10 minus 3. So f of 2 in this instance is a positive 3. Function notation is awesome for a lot of different ways. Notice that my specific 2 value that I have here can only be an output there of 3. So 2 in this instance will give you a 3 and only a 3. Because remember, the x's can't repeat on that. Another way to write this, just for fun, is a coordinate point. If you know that your x is 2 and your y is a 3. So function notation and a coordinate point are the same thing. So it's awesome to have function notation because that's really just another way to write a coordinate point. Cool, let's do more. What if we have something super amazing like this? We end up with example 6c, and I have g of x is equal to a 2x plus 3, and I want to find g of a plus 1. So instead of just a number in there, I have the whole a plus 1. So literally all of this a plus 1 is going to replace that x. So it's 2 times an a plus 1 plus 3. Then you just simplify. So g of a plus 1 is actually 2a plus 2 plus 3, because you have to distribute that 2. So g of a plus 1 is 2a plus 5. Cool. Now you could also write that as a coordinate point, because it's fun. So anytime you have an input value of a plus 1, your output value will always be a 2a plus 5. Cool, but really this is what we're actually looking for. We're just doing the coordinate point because literally it's just fun. We're just having a good time here, doing a little math. Cool, let's do more. Okay, so with this example 7, we're going to find f of 3, and we're going to show it in multiple ways. We've already looked at what it takes to work with an equation. You're just plugging in that 3. Now what happens if I have something like this? So I have my set notation here, and notice I am already given the fact that it is a function, so I don't have to worry about whether or not it is, but you can do a quick check and see none of your x's repeat, so that's legit. If I want to find f of 3, what I'm saying is when is 3 my x value? So you go through on your x's until you can find where 3 is your x value. And remember how we also talked about function notation as a coordinate point? So what is the output value of f of 3? Simply 1. I get a lot of people that put answers in there of the coordinate point 3, 1. No, the output is 1 because the input is 3, so then your only answer on this is your 1. Good. What if we have something awesome like this part B, where my domain And I'm writing this out because it'll be mapping. My domain here is -2, 3, and 10. My range is 6, 5, and 12. And I have that mapped that way. And again, my ultimate goal here is to find f of 3. That's a parenthesis. So I'm looking over here at my domain. Oops, sorry, I meant to write range. So I'm looking at my domain and I'm trying to hone in on the 3. So 3 is mapped with what? The 5. Good. So if I'm looking at mapping, you can also find your function notation. Just look for your input or your domain, which is your 3. What's it in relation to? 5. That's it. Pretty cool, huh? Okay, my goal here again is to find f of 3. So I'm going to zoom in on my graph here a little bit so we can see this closer. Okay, so if my goal is to find my f of 3, remember your 3 is the x value. So I'm going to start here where 3 is the x, and I'm going to go up to my graph and see where my graph is 3. So when x is 3, what do you notice is the y value? 4. Good. So really, f of 3 in this instance is 4. Remember, function notation is the same thing as a coordinate point. All right. So let me zoom this back here a little bit. Oops. Okay, so I know now that f of 3 here is 4. So let's go ahead and put that up here at this point. So if f of 3 is 4, now look at what else we can find. What if I want to know x is what value when I have f of x equal to 1? F of x stands for what again? Y. Good. So if f of x is my y value, I want to figure out what is my x when my y here is equal to 1. So let's see if we can hone that in here one more time. Oops, almost. When y is equal to 1, my graph is off just a tad there. I'm going through this value. So when y is equal to 1, what is x? 0. 0. That's the goal here with this. So you look at your graph and you can either be figuring out what your x value is or what your y value is. So my x in this instance is equal to 0. So we actually have f of 0 is equal to 1 as my coordinate point because my x is 0 there. Good. So it doesn't matter how you're looking at function notation, you can come up with all different types. Okay, the last thing we're going to look at here with functions is increasing, decreasing, and constant. The kicker to these problems is to look at your graph from left to right over the domain. Now, what does domain stand for? That's right, the x values. So anytime you're writing out an increasing, decreasing, or constant, you want to go from left to right, and it's always, always, always going to be the x values. Okay, so let's do this thing. I want to know where is my graph increasing, what is decreasing, and where is my graph constant. So whenever you look at this, you're going to go from left to right. So take your finger and follow your graph. What is my graph doing here from left to right? What motion is happening? Decreasing. Good. Even though the arrow is going up, do not look at the arrows in this instance. If you want to state the domain and range, etc., then you're looking at your arrows. But in this instance, those arrows can be deceptive. Just follow your finger along the graph, and I am decreasing. Now, I think it's helpful a lot of times to say, okay, I am decreasing up to this point, so that's my value that I'm looking at. My graph is going to decrease. Now the arrow's going on to infinity. So from negative infinity all the way up to 1, my graph is decreasing. Now look at 1, whenever I'm decreasing, what is my graph doing? I have a hole. So am I going to use parentheses or brackets? parentheses. Good. Bracket only happens when it is like a solid dot or my graph is solid. Anytime you have a hole, then you know it's going to be parentheses. Okay, now look at what's happening here. My graph is going up and then flatlining. So if my graph is going up, what motion is that? Increasing. Remember, this is the domain. So my domain of my function is increasing. So from my graph here to here. So bring it down to the x values. So from 1 to 3 is where your graph is increasing. Now that can be deceptive because your motion is going up. However, your answer is the domain. So make sure you're paying attention to that. Now the same thing is happening here whenever I'm looking at my graph and I want to see what's happening on this last part. So again, I'm following along my graph and it's steady eddy. So what's that called? Constant. Exactly. So from here to forever really is constant. So I'm going from 3, oops, pardon me, that's a bracket. From 3 to infinity, I'm going constant. The big kicker is it's over the domain, so make sure you're just using your x values and then you follow along with the graph to determine what it is you're doing. Awesome, great job on functions.